All right, so we are going to be talking about the properties of logarithmic functions in class on Friday. You should have learned that b, u, and v, which you'll see here in a minute, are all positive real numbers. B cannot be 1. C can be any real number. Okay? All right, so as we're going through, just remember those. So our first property is something called the product rule. And the product rule says that if I have two things that I am multiplying together in the argument, this is called the argument of the log. If I'm multiplying those two things together, I can break those up into log base b of u plus log base b of v. So I can break those up. Okay? And that might help me because one of those might be simplifiable and it might just become a real number and then I get an exact value of it. So that's the product rule. And the product rule works when we are expanding. The product rule is going to work that way. When we are condensing, which you also will have to do in this part, is going the other way. So you have multiple logs, we condense it down into one log. Okay? The next one is called the quotient rule. So here now, if I am dividing something in the argument of a log, then I can write that out as log base b of u minus log base b of v. Again, expanding, I would go to the blue from the black. Condensing, I would go from blue to black. Okay? Our next one is, well, that jumped on me every once in a while, it'll do that. Okay? The next one is the power rule. The power rule says that if I have something taken to a power here in the argument, I can take this exponent and I can put it out in front. So then this would become c times the log base b of u. And the last logarithmic rule that we have to deal with is something called the change of base formula. And the change of base formula tells me that if I have this log and I want to evaluate that log, I am going to take the common log, log base 10 of u, and I'm going to divide that by the common log, log base 10 of b. Or I could take the natural log of u and divide that by the natural log of b. Okay? So I could do that, and then I can evaluate that, and we'll get more into that later on. Okay? So let's do an example here of each of these expanding logarithms. Okay? So on this first one, I look at what's inside my argument here, and I see three distinct terms. Okay? First off, I see that this is 100 times x times y to the fifth. So I can break that up into the log of 100 plus the log of x plus the log of y to the fifth power. Now I ask myself, so now I've got it expanded out, now I just need to kind of make it look nice and pretty. Okay? So this particular log here, what exponent would I have to put onto 10, because remember that's log base 10 there, to get 100? Well, that is 2. So that one becomes 2. Log base x is just, log of x is just log of x. Okay? There's nothing that I can do to this particular one. On this last one, what I can do is I can take this exponent of 5 and I can bring it out in front. So my final expanded log looks like that. Okay? So that is how we expand logs. Okay? Now, will every single time, will this term here condense down, or will that be able to become just a number? No, not every single time. If this were the log of 50, okay, we would leave it as log of 50 plus log of x plus 5 log of y. Okay? It just so happened that in this one, it was able to use my logs that we learned on Friday to make that become the 2. Condensing now. Now I know that I'm going to be condensing because I'm starting with multiple logs. When I start with one log, I'm going to expand. When I start with multiple logs, I'm going to condense it down. Okay? So the first thing that I would do, if this were me, is I would utilize my power property in reverse. So this is a number, a coefficient out in front. That goes into the exponent. This is a coefficient out in front. That goes into the exponent. So this becomes log of x to the 1/2 power minus log of y cubed. Okay? Now, this is a subtraction sign. So that is a quotient rule. So that I'm going to be dividing those terms. So this becomes log of x to the 1/2 power divided by y cubed. Okay? Or, if we wanted to, we could write this as log of the square root of x divided by y cubed. But this is all inside a set of parentheses, okay? Because that whole fraction is my quotient. Okay? Change of base formula. Okay? So the change of base formula, what exponent? Remember, logs are exponent finders. And I know the first thing that I'm going to tell you, and the first thing that I told you on Friday in my classes was logs are exponent finders. In my brain, I am thinking here, when I see log base 3 of 8, I'm thinking, what exponent can I put onto 3 to get me 8? So I would go log base 10 of 8 divided by log, divided by log base 10 of 3. Or I could do the natural log of 8 divided by the natural log of 3. Now, on a calculator, on your regular old TI-30 calculators or any old scientific calculators, okay, you can do that, okay, so you would just type in log of 8 divided by log of 3. And that's going to give me that. Now, on a scientific calculator, you wouldn't see this base 10. You would just see the word log. Okay? So I get 1.89279. Or we could take the natural log of 8, and we could divide that by the natural log of 3, give us the same thing. Now, just to show you that that's what it is, if I take 3 to that answer, I get 8. Okay? It's the exponent that I have to put onto 3 to get 8. And it makes sense to me that this is approximately 1.89, I believe it was 2, 1.893. Okay, that is an approximate because 3 to the first power is 3, and 3 to the second power is 9, and 8 falls in between 3 and 9. Okay? And it's closer to 9, so that one should be closer to 2. Little logic check for you. Okay? We'll pick up on this. We'll do a couple warm-up problems of this stuff on Monday morning, and then we're going to jump right into solving logarithmic equations.